Okay, before we dig into examples of using the zero product property, we need to be careful about when this thing doesn't apply. So, recall again, zero product property, if A times B equals zero, then A equals zero or B equals zero. Question, if A times B equals 14, can you conclude that A equals 14 or B equals 14? No, we can't do that, right? Maybe A equals 7 and B equals 2. Maybe A equals 2 and B equals 7. Hey, maybe A equals -1 and B equals -14. There's actually lots of possibilities for two numbers to multiply together and produce the number 14. So we have to be very careful when using the zero product property. Here's with the labeling here, good versus bad, to show what's an example of good is when you see A times B equals 0, you can conclude A equals 0 or B equals 0. However, if you see A times B equals 10, you should not go to concluding A equals 10 or B equals 10. So that does not work, just like if you had the product being 14. So just similarly, if the product is 10, that doesn't work. You really have to have a 0 here. The point is the zero product property only works if you have a product equaling 0. And so the name is important. A lot of times people try to not pay attention to the name of this thing, but it is called the zero product property. Right now I'm going to emphasize the word zero. Right? Zero product property. You got to have a 0 on one side, and then you have to have a product on the other. Right? A times B. So for this reason, you should know this property by name. The first word, 0, helps inform us when this property applies. The next word, product, is actually also helpful in informing us when this property applies. Okay, just to double check, question, if P times Q equals 6, can we conclude P equals 6 or Q equals 6? No, maybe P equals 3 and Q equals 2. There's other combinations possible. If P times Q equals 7, can we conclude P equals 7 or Q equals 7? We still can't hear. I think sometimes people get thrown off thinking, oh, now it's fine because 7 is a prime. And this is not okay. Maybe P equals a half and Q equals 14. I mean, look, maybe P equals 1 and Q equals 7. It's just, but we don't know for sure, right? So it's not really something here to try to treat primes different from composites. That's not it. The point is you have to have a 0 on one side in order to use this technique. If P times Q equals 0, can we conclude P equals 0 or Q equals 0? Yeah, then we can. Either P must be 0 or Q must be 0 or both. The way that we write this is what you see in the yellow box here. P equals 0 or Q equals 0. Be sure to write the word or. That is going to be required. I will be looking for that. So again, yeah, be sure to write the word or. Sometimes people will take PQ equals 0 and then write P equals 0 and Q equals 0. And usually what happens is people write Q equals 0 directly underneath. It becomes really hard to get the word or in there, right? When writing one equation on top of the other, it's very easy to forget the word or.